Hello everyone. Today I have a question. So today I have a question from physics. Basically I upload video on mathematics. Today I have a question from physics. Chapter is work power energy. Very good level question. The students who know about kinematics, NLM, that is Newton's law of motion, work power energy at good level, this question is for them. The students who not know, this question is not for them. So at first the student please try this question by pausing the video, and this question tells a smooth ring of mass capital M is threaded on a string whose ends are then threaded over two smooth fixed pulleys with masses small m and small m prime tied onto them respectively. The various portions of strings are vertical. The system is free to move. What is the condition if capital M alone is to remain at rest? So this is the figure given here. Sorry. So here it is given that it is a massless rope. So we know in massless rope tension is same to everywhere. So in the string, total string tension is same. So we assume that here tension is T to everywhere. So T so tension is same everywhere, and we assume as it is in the question it is written that capital M alone is to remain at rest. So we assume that it is in the rest position. So by pausing the video, solve the question. I also solve the question. Thank you. So look, because it makes many times, so I write the whiteboard. I write in the whiteboard the solution and I tell the explanation. And because it takes many time, so I not write in instant. So this is the figure given below. At first we have to draw the FBD, that is free body diagram. How to draw free body diagram? So here it is M prime, so in downward direction M prime G, and in here also mg in downward direction, here capital Mg in downward direction, in upward direction tension T, and here in this position Mg stable 2T, that is T plus T, here 2T. So Mg is equal to 2T. We can write, and here we can find the value of tension, that is T is equal to capital Mg upon 2. As it is in rest, we assume that here acceleration is in downward direction and here acceleration is upward direction. So in Newton's law of motion, it says in Newton's law of motion, second law of motion, here it tells that F net is equal to mass into acceleration. So we apply at first here we apply at first F net is equal to mass into acceleration. When we apply, please look that here there are two forces, M prime G and tension T. So in M prime G and tension T, which is greater? How can we say? By acceleration. The acceleration's direction and M prime G's direction are same. So yes, so acceleration's direction and m prime g's direction are same, that's why m prime g is greater than tension. So we can write that m prime g minus tension T is equal to force is equal to m prime A. That means we can write that m prime g minus T is equal to m prime A. Please neglect these things at first. What I tell, please follow. Please neglect these things. So and we also apply here also apply the second law of motion. It tells here tensions and accelerations direction are same. So here tension is greater than mg, that means T minus mg is equal to here T minus mg is equal to ma. That means we can write that T minus mg is equal to ma. Then we have to think that here we get the tension's value. We get the tension's value that T is equal to mg upon 2. And here also we get tension's value by what? Adding or subtracting. We think that it by subtracting, because in adding tension is cancelled out. So by subtracting we can get, we have to change the signs. So here it is plus, so we write minus, minus, plus, plus, minus. So we changing the signs and now we subtract. So here it is 2t, g is common, so here minus g into m plus m prime, we write, and here acceleration is common, so m minus m prime into acceleration, we write. Then in the second step, what we do, we have to do simple this minus g into m plus m prime, this place to here, so it is plus g. So look at first, in m minus m prime into acceleration plus g into m plus m prime. Then we have to write acceleration in terms of g. So from this equation I write in red mark. So from this equation we get the value of acceleration. What? Acceleration is equal to T minus mg upon m. So we can write it again, T by m minus g. So we also write acceleration, instead of acceleration we write T by m minus g in the third step. Please don't step jump, because I have practiced, so I step jump. In your case, please don't step jump. So sorry. So yes, next we do only multiplication. So here T by m into m is equal to T, so we write T. M prime minus m prime into T by m is equal to T minus Tm prime by m, that is we write here. Here minus g into m minus mg, we write here. Then minus m prime into minus g is equal to minus minus plus, so plus m prime g, so we write here. And next here we have to multiply this term also, so this term is here g into m, that is mg, so mg plus mg, and here also plus m prime g. so plus m prime g. Then we find that plus mg minus mg find, and then we cancel out, so we cancel these two terms. Then minus plus m prime g and plus m prime g, that means 2m prime g, and this t term we displace here left hand side, right hand side to left hand side, that is 2t minus t, that means t. And then we displace this term to left hand side, then finally we got t plus t m prime, my mistake, t plus t m prime upon m is equal to 2m prime g. Then we get that t plus t is common, we take t common, and then t into, look at first here because I not write that, so look t into 1 plus m prime upon m is equal to 2m prime g dot dot dot, that means 2m prime g. First look in LHS, so then we can write that t into, when we add this term, then we find m here, m into 1, that means m, so m plus m prime, which is equal to 2m prime g. So we write it here. Basically I'll do step jump, so that thing, and then this term we only cross multiply, so m into 2m prime g is equal to 2m into m prime g, and divided by, it is m plus m prime into. Next thing is here we got the value, these tensions value, final tensions value, and at first what I got the value tensions mg upon 2. Then we do basically equate these two values, then we equate these two values and find what mg upon 2 is equal to 2m into m prime up g upon m plus m prime, and then g and g is cancelled, and then we multiply 2 into 2, that is 4m into m prime. So m here, it will look like m is equal to 4m into m prime, 4 into m prime, m into m prime upon m plus m prime. Then what we do, we displace 4 to here in the denominator of m, left hand side denominator, so m upon 4 is equal to m into m prime upon m plus m prime. So what we do, we only reciprocal this 4 m by 4, we reciprocal this, it forms 4 by m. So when we reciprocal these also this RH term we also reciprocal, because one side reciprocal is not allowed. So 4im, then it looks like 4 by m is equal to m plus m prime upon m into m prime. Then what we do, sorry, by mistake my handwriting is so mistake, so wait, first I check it. So what we do, it is 4 upon capital M is equal to 1 upon small m plus 1 upon small m prime, and this relation we got. Then we have to just check the option. Here the option matches to option number A, that is here m 4 upon m, this option 4 upon capital M is equal to 1 upon m plus 1 upon m prime. So option number A correct, yes. So thank you everyone. Bye. Hope you like this video. Subscribe my channel. Hit the bell icon. So thank you everyone. Bye. Stay healthy. Stay safe. मिलते हैं नेक्स्ट वीडियो में. बाय. तब तक के लिए बाय.